Okay, the next is systems. You have two questions with systems. One will be, I prefer you to use substitution, as I'm going to give you two functions where a variable is already by itself. So I'll have like y equals 3x plus 4, and maybe like y equals negative 2x plus 3. So the key is you got to figure out a solution, right? An ordered pair would be your solution. You got to figure out an x and a y that works for both of them. And 29, to solve its system, I would prefer you to do elimination, because I'm going to give you two functions that are already in slope-intercept form. So if we have maybe something like this, it's easier to do elimination. Now, the reason why in 28 is easier to do substitution is, like I said, y is already by itself. So since y is 3x plus 4, I can put that into the other function. So instead of writing y, I'm going to substitute 3x plus 4. In other words, replace it. So y is 3x plus 4. So I'm going to take that 3x plus 4 and put it into the other function. Well, then that just gives you an equation in which you have variables on both sides. So you need to get that combined. And now you have a two-step. And then you have your answer. Part of your answer. All right, you only have negative 1/5. Now remember, your solution is an ordered pair. So you're not done. You have to take that negative 1/5 and you can plug it back into any function in the original. So I could also plug it into the top if I wanted to, as it has to work for both anyway. So y equals negative 2. I'll put this substitution maybe in blue. So since x is negative 1/5, I'm going to put negative 1/5 right there. Plus 3. Alright, so now I have 2/5 plus 3, which is 3 and 2/5. Okay? And that is the solution. Alright, that ordered pair. Negative 1/5, 3 and 2/5. How do you check to see if that's right? Okay, you would take and plug it back into both functions and see if it's correct. So, for example, I say, well, I should get 3 and 2/5 out when I take 3 times negative 1/5 and add 4 to it. Okay, question is, do I? Well, this is negative 3/5 plus 4. Okay, well then that's going to be 3 and 2/5. Check. And you can plug it into the other one. So I should get 3 and 2/5 out when I times it by negative 2. Negative 2 times my x, which is negative 1/5, and add 3 to it. Okay, well again, here I have a positive 2/5, because a negative times a negative is positive. And I add 3 to that, and once again, I get 3 and 2/5. So you should always be able to check your work. Now, with elimination, like 29, all right, neither variable is by itself. So you get to manipulate, as long as you do it to both sides, okay, you can multiply any number you want such that you have opposite coefficients. Now, I'm going to pick negative 2. Okay, again, as long as you do it to everything, the function will remain equivalent. So if I take negative 2 to everything, I now have this function. Now, this function here, I'm going to keep it the same. All right, so I'm just going to rewrite it here. 2x minus 3y equals negative 5. I don't need to manipulate that one. Although you could, if you had to, you can manipulate both like we did before. Now, the whole idea is why you want opposite coefficients is because now, as long as the x's and the y's are lined up and they're opposites, adding opposites will cancel. Right? This is really 0x. Negative 2 plus 2 is 0. So 0 times x is just 0. All right. Well, negative 8y plus a negative 3y is going to be a negative 11y. So that's why we call it elimination, because it eliminates one of the variables, because 0 times anything is 0. So technically, we never really write that. It's just gone. But that's why it's gone. And I divide it by negative 11, and then I get 1. Just like the other one, I have to figure out what x is. So I got to plug it back into any function that I want up above. I'm actually going to pick the very first function that I didn't even manipulate. Okay, so x plus 4y, so x plus 4y, which is 1, so scroll up just a little bit, equals 3. So I can plug it, so plugging that in, I realize that x is negative 1, because when I subtract 4, right, 3 minus 4 would be negative 1. So the order pair, negative 1, 1, and you can plug that back in and check your work just like we did with 28 if you wanted to. So one problem with substitution, one problem with elimination.